Hi all, welcome back to System Verilog sessions. In this video, I'm going to discuss about cross coverage. So what is cross coverage? A coverage group can specify cross coverage between two or more coverage points or variables. A coverage group can specify the cross coverage between two or more coverage points or variables. So here cross means the cross product between the coverage points or variables. Cross product between two or more coverage points or variables. And what is the difference between coverage points and variables? So variables means when in the declaration time we will declare the signals, right? Int data, int address. So that is a variable, and the coverage point is nothing but when you write the cover point for the variable, that becomes the coverage point, right? Cover point address, cover point data, that is a coverage point, and when you declare the signals, those becomes variables. Okay, so why I'm telling the difference is because in future I'll be using this point, coverage point, coverage point. So that time you need to understand that coverage point means the cover point of the variable, and when I say variable, it's a variable. Okay, and cross coverage is specified using the cross construct. So cross is a keyword which is used to define the cross coverage. When a variable v is part of a cross coverage, system verilog implicitly creates a coverage point for the variable as if it had been created by the statement cover point v. Okay, that means when we perform the cross coverage between variables, I'm talking about variables only. When we perform the cross coverage between variables, what system verilog will do? It will implicitly creates a coverage point for the variable. For example, here I'm not using the variable v. Okay, here I'm using the variable address and data. So I'm performing the cross coverage between address and data. What I will do? I will write cross address comma data. Okay, so here my intention is I want to generate the cross product between address and data. But what system verilog will do? System verilog implicitly creates a coverage point for the variable. So when the system verilog implicitly creates the coverage, when the system verilog implicitly creates the bins, when we write cover point address, cover point data, then only the implicit bins will be created, right? But we want only the cross product between address and data. But what system verilog will do? System verilog will create the implicit bins for the address and data, which is not required here. We want the cross product between address and data. So it will generate the cross product between address and data. With that, it will generate the implicit bins for cover point address and cover point data, which is not required. Okay, so this is what happens when we use the cross product between address and data. We can see that in the coverage report. Okay, so in the coverage report, even though if you write cross of address comma data, you will see cover point address, cover point data. When you write cover point address, what you will get? The implicit bins of the address, right? If the address is 3-bit, 2 to the power 3, 8 auto bins will be created for the address. If the data is 4-bit, 2 to the power 4, 16 auto bins will be created. So you will see the in the report, okay, coverage point of address, coverage point of data, and the cross product between address and data. So we want only this thing. This is not required, but system verilog will implicitly creates the coverage point for the variable. So that's why a cross involves only the coverage points. Okay, we mostly write the cross coverage between the coverage points and not between the variables. We can write between the variables, but this is what happens. Okay, here it is not required. Still, it will create the implicit bins for it. So we mostly use the cross coverage between coverage points. Okay, what is coverage point? The cover point of a variable. So this is the coverage points. Okay, here you can explicitly write the bins, right? Bins low is equals to some value, bins high is equals to some value. So this is the coverage points. So we always perform the cross coverage between coverage points. And expressions cannot be used directly in a cross. A coverage point must be explicitly defined first. That means you cannot directly perform the cross coverage between expressions. Okay, you cannot write like cross a plus b comma a minus b. You cannot write like that. You need to create the coverage point for the expression first, then you can write the cross product between the coverage points. Okay, I'll show you in the example. And the syntax to write the cross coverage is cross coverage label and cross this is the construct, and here more than two coverage points are variables. Okay, cover point 1, cover point 2, cover point n. So more than two coverage points we can include, or variables we can include here. So here I have an example, bit 5 down to 0, address comma data. Address and data has 6 bits and valid is 4-bit and enable is single bit. And here I have a cover group, and here I am defining the cover points. Okay, so CP1 cover point address and enable. This address and enable is the expression and it is labeled as CP1. Let's say this cover point creates 10 bins. Okay, 10 bins will be created. I'm just giving the example. And what is CP2? CP2 cover point data. So here for data, implicit bins will be created because we are not writing any explicit bins. So for data, implicit bins will be created. And how many implicit bins will be created? Data is 6 bits. So 2 to the power 6 is 64 bins will be created. And now we are doing cross between CP1 and CP2. So what is CP1? CP1 is an expression, right? So here you can see expressions cannot be used directly in a cross. Here I cannot write cross address and enable comma CP2. I cannot write like that. A coverage point must be explicitly defined first. That's why a coverage point is here defined. Okay, so CP1 is the coverage point now. So cross CP1 comma CP2. So what is CP2? CP2 is data. So we are doing the cross between CP1 and CP2. And how many cross products will be generated here? We know that CP1 will create 10 bins and CP2 will create 64 bins. So 10 cross 64 is 640 cross bins. Okay, so this is how to find the cross bins, cross products. And the last one is cross valid comma CP1. So cross coverage between variable and expression. So here valid is 4 bit. That means 2 to the power 4. 16 bins will be created for valid. And what is CP1? CP1 will create 10 bins. So 16 cross 10 is equals to 160. For example, if I am doing cross between address and data, okay, cross address comma data, how many cross bins will be created for it? We know that address is 6 bits and data is 6 bits. So 2 to the power 6 into 2 to the power 6, that is 64 into 64 cross bins will be created for the this cross address comma data. Okay, so this is how to find the cross product of variables or coverage points. No cross coverage bins shall be created for the cover point bins that are specified as default, ignore or illegal bins. So when you declare the cover point as ignore bins or illegal bins, you cannot perform the cross coverage between those two. Okay, so no cross coverage bin shall be created for the cover point bins that are specified as default, ignored or illegal bins. And a cross coverage is allowed only between coverage points defined within the same coverage group. That means when you have multiple coverage groups and if you want to perform the cross coverage, you have to take the cover points which is defined within the same coverage group. Okay, so because you are performing the cross coverage in that cover group, right? So you need to take the coverage points which is defined within the same cover group. You cannot take other coverage group variables or coverage points to perform the cross coverage in this cover group. Okay, you need to take the coverage points defined within the same coverage group. And coverage points defined in a coverage group other than the one enclosing the cross cannot participate in a cross. That means, as I said here, when we are performing the cross coverage, we need to take the coverage points defined in the same cover group. We cannot take the other cover group variables or coverage points to perform the cross in this cover group. Okay. And attempts to cross items from different coverage groups shall result in a compiler error. So if we do so, we will get the compilation error. Okay, so this is not allowed in the cross coverage. We cannot take the other cover group coverage point or variables to perform the cross coverage in another cover group. Okay, so we need to take the cover points which is defined within the same cover group. Otherwise, we will get the compilation error. So now we will see coverage constructs. So in system verilog coverage, we have multiple constructs such as if construct, bins of construct, intersect, with clause or matches. Okay, so we will see one by one. The first one is if construct. So you know about if statement, right? How if statement will work. So when the condition, based on the condition, it will decide whether to execute the statement or not, right? If the condition is true, the statement within the if block will be executed. Otherwise, the statement will not be executed. Similarly, in the if construct. So to decide whether to include or exclude the cover point in the coverage, we can use the if construct. Okay. So the expression within the if construct provides feasibility to exclude the cover point in the coverage if an expression is evaluated as false. Okay, if the condition is false in the if construct, then it will exclude the cover point in the coverage. If the condition is true, then it will include the cover point in the coverage. Okay, so it's similar to if statement only, but the keyword is IFF. Okay, if. So the expression inside the if construct decides whether to include or exclude a cover point from the coverage collection. Okay. So here is the example: cover group C group CP1 cover point data if not reset. That means what does the meaning of this statement? Cover point data if not of reset means the data will be sampled if the reset signal is 0. Okay, so this cover point data will be collected in the coverage if the reset signal is 0, because here I am using the active reset. Okay, so if reset is 1, reset will be applied. If reset is 0, then this cover point data will be collected in the coverage report. Okay, so by to enable or disable or to include or exclude the cover point data in the coverage, we can use the if construct. Okay, here we have to include the expression. Okay, basically when we have the reset signal or enable signals, that time we can use the if construct. And the next one is bins of and intersect construct. So we will see bins of first. As the name suggests, bins of other cover point, right? We can say bins of other cover point. So if you have defined the bins in one cover point and you wish to incorporate the same bins into another cover point, then you can use the bins of construct. Okay, so this bins of allows you to reference those existing bins without redefining them. So the bins of construct is the bins of its expression, which can be either a coverage point or a coverage point bin. So what is coverage point? Coverage point means the cover point of a variable, right? It can be explicitly defined or implicitly defined. And what is coverage point bin? Coverage point bin means when you define the explicit bins for the coverage point, you can say the particular bin. Okay, the particular bin is called as a coverage point bin here. So if you see the syntax, you can understand bins of coverage point. So bins of is the keyword, bins of is the construct, and coverage point is the expression. And what can be the expression? Expression can be a coverage point or coverage point bin. If you see here, CP1 cover point V. So this is the coverage point. Okay, now CP1 is the coverage point, and what is coverage point bin? This bins V1 and V2. These are all the coverage point bin. Okay, coverage point bin of CP2. So here bins xy1 is equals to bins of cp1. So whatever the bins have created for cp1, the same bins will be created for xy1. Okay, and xy2 is equals to bins of cp2 dot v2. So xy2 can have the bins of this v2. So what is v2? Bins v2 is equals to 4 5 6, right? So three values are there, so the three values will come here. Okay, bins of cp2 dot v2. So single bin will be created here. And the third one is intersect construct. So the intersect construct is generally used in conjunction with the bins of construct, which is used to exclude or include a set of values of bins that intersect a desired set of values. So we usually use the intersect construct with bins of construct. So when you write the bins of construct, what it will do, the intersect construct, it will include or exclude the set of values of bins that intersect a desired set of values. So if you see the syntax, bins of coverage point intersect range of values. So the bins of coverage point, if it intersect with the range of values, then those values will be covered here. Okay, so the intersect construct will be used in conjunction with the bins of construct, which is used to exclude or include a set of values of bins that intersect a desired set of values. Okay, we will see in detail in the next slide. So if you see here, we can see how to include and exclude the bins using the intersect construct. Okay, so the first one is bins of CP intersect R. What it means? The bins of coverage point CP, the bins of coverage point CP whose values intersect the range specified by R. Okay, the bins of coverage point CP whose value intersect the range specified by R. This is to include the bins from the CP. Okay, and what is this? Here we are using the neg operator, neg bins of CP intersect R. That means the bins of coverage point CP whose values do not intersect the range specified by R. So out of that we will select the values bins from the coverage point CP. Okay, so this is how you can use the intersect construct to include or exclude the bins from the. And one more point is the cover group value range. The cover group value range means this R. Okay, I'm talking about the range. The cover group value range syntax can specify a single value, a range of values, or an open range, which denotes the following. So the range can be single value. So it can be single value like this, or range of values 10 down to 20. It's a range, right? So it can be a range or an open range. So what is open range? Open range is defined when you use the dollar. Okay, dollar down to value or value down to dollar. So dollar down to value means the set of values less than or equals to value, and value down to dollar means the set of values greater than or equals to value coverage point. Okay, for example, if you see dollar down to 50, so dollar down to 50 means it covers all the values less than or equals to 50, and 100 down to dollar means it covers all the values greater than or equals to 100. Okay, so this is the open range, and this is a single value, and this is the range of values. And the bins selected can be combined with the other selected bins using the logical operator and or. Okay, so you can use the logical operator when you are using the bins of or intersect construct. So this is all about the if and bins of and intersect construct. Next we will see the example for this construct. Okay, so now we will see the example for bins of and intersect construct. Okay, so I'll explain about the if construct in EDA playground. I'll explain all the examples in EDA playground, but this is like bit confusing. That's why I will explain here once. Okay, so we will see how to perform the cross coverage and how to see the bins of an intersect construct. So here I have two variables, v underscore a and v underscore b, and it's of 8 bits. Okay, and in the cover group I have 3 coverage points, a, b, c. Okay, a is for v underscore a variable, b is for cover point v underscore b, and c is for cross coverage between two coverage points. Okay, here I am performing the cross between two coverage points, not between variables. Okay, a and b is the coverage point, so cross a comma b. So the first one is bin c1 is equals to not bins of a intersect 100 down to 200. You can read it in any way. Okay, I will read like this, not bins of a intersect 100 down to 200. So what does it mean? Bins of coverage point a whose values do not intersect with the range specified 100 down to 200. So what is bins of A first? We will see what is bins of A. Bins of A is A1, A2, A3, A4. There are 4 bins, right, for coverage point A, and whose values do not intersect with the range 100 down to 200. So first we will see whether A1 intersect with the range 100 down to 200. No, right? And 64 down to 127 intersect with the range. And this will also intersect with the range 100 down to 200, and this one is also intersect with the range 100 down to 200. So only the A1 bin will not intersect with the range 100 down to 200 because it's less than 100. So we have only A1, and we need to cross this A1 with B because we are doing the cross product between A comma B, right? So now we've got bins of A whose values do not intersect with the range is A1. So A1 cross B1, A1 cross B2, A1 cross B3, A1 cross B4. So total 4 cross bins will be created for C1. Okay, 4 cross products, A1 B1, A2 B2, A1 B3, A1 B4. So there are 4 cross products. What is C2? Bin C2 is equals to bins of A dot A2 or bins of B dot B2. So here we have a coverage point bin. So what is this? This is a coverage point, and if you write like this, it's a coverage point bin. So here we are selecting the coverage point A. In that coverage point A, we are selecting only A2. Okay, bins of A dot A2, and here bins of B dot B2. In the coverage point B, we are selecting B2, and here we have OR operator. OR means we have to add the bins of A dot A2 and B dot B2, right, when we do the cross product. So let's see the first one, bins of A dot A2. Now what we have to do? We have to find the cross coverage between, we are performing the cross between A and B, right? So in the A, we are selecting only A2. So now we have to do cross between A2 and B. Okay, A2 comma B1, A2 comma B2, A2 comma B3, A2 comma B4. Total 4 bins are created when we do the cross product between A2 and B. Okay, here we have OR operator and bins of B dot B2. Now we will see the B2. Okay, so in the B, we are selecting B2, B2 comma A1, B2 comma A3, B2 comma A4. I am not considering B2 comma A3. Why? Because we have already covered this one. A2 comma B2 we have done right before. So I am not doing B2 comma A2 now. Both are same only. So only one time is fine. So total here 4 bins, here 3 bins. Total 7 cross products are created. Okay. If you see here A2 comma B1 here. First A dot A2. A dot A2 means this one. We are doing the cross product. So A2 B1, A2 B2, A2 B3, A2 B4. And next one is OR operator. Here B dot B2. So again we are doing the cross product between B2 A1, B2 A3, B2 A4. I am not doing B2 A2. Why? Because A2 B2 is already covered. Okay. If you are learning this concept for the first time, then you may feel difficult, but if you go through the same example multiple times, or if you go through the other examples, you will feel like you will understand. Okay, because if you understand one example properly, then you can write any examples or you can understand any example. And anyway, we are not going to do like this. We are just writing the example and the tool will take care of everything. The tool will take care of the bins, but for understanding purpose I am telling like this. Okay, so it's not in mathematics, it's a code, right? So tool will take care of the bins, so we just have to understand the concept. Okay, and the next one is bins C3 is equals to bins of A dot A1 and bins of B dot B4. So here we have AND operator. So when you are dealing with logical operators, you should be careful. Okay, if you know the concept of sets, then it will be easy for you to understand. Okay, so bins of A dot A1 is this one. So first we will see A1 comma B1, A1 comma B2, A1 comma B3, A1 comma B4. And what is bins of B dot B4? This one, B4, right? So B4 comma A2, B4 comma A3, B4 comma A4. But we have a AND operator here. So it's not an OR operator to add both one, right? So we need to, like, we have to find the intersect of value. So here Here we have a AND operator. AND means A dot A1 and B dot B4. Only one cross product, A1 and B4, right? So A1 and A1 comma B4 is the only one cross product that satisfies the AND operation. Okay, so one cross product will be created for bin C3. So you just understand the logical operators first, then you will understand how to do the cross product. Okay, so this is about the bins of and intersect construct. Next we will see with clause and matches construct.